Hey guys, Mr. Baldwin here. We're going to work on finding the epicenter of an earthquake. So I've got this document. You can find it up on the website if you click on the link down at the bottom of the video. And just make sure you put your name on it, and we'll walk through the first example together to give you an idea on how to do this. Remember, you're going to need a compass and a pencil to do this. I'm doing it in pen just because it's a little easier to see. Do it in pencil just because it's easier to erase. So, first step, what we're going to do is we take our seismographic data. Okay, so these are the seismograms that read out from the seismograph, and we're using this to try and figure out the distance to the epicenter. Okay, so what we're going to do is we're going to look at Chicago's data first. We'll go all the way through Chicago so you can do it on your own after that. Okay, so I look for the first vibration of my earthquake. And that first vibration we know is going to be the P wave. Okay, and the P wave shows up at 18 seconds. Okay, then I follow through and I go all the way until I see the next major vibration. All these are little minor vibrations that we see. We're looking for something major. So right about here, and this is going to be our S wave, and this is going to be at about 153 seconds. Okay, so what we can do is we can use this to fill out our data table. So if we go to the next page, we can fill out our data table right here for Chicago. So the P wave arrival time was 18 seconds. S wave arrival time was 153 seconds. Then I can find out the lag time based on that. Remember, the lag time is simply the S wave minus the P wave equals lag. Okay, so for us this is going to be 153 minus 18. So if I do my quick math, this should give me 5 and 335 seconds. 135 seconds. Okay, that's my lag time. Remember, the greater the lag time, the farther away from the epicenter you are. Okay, from this I can figure out my distance to the city. Okay, so I have 135 seconds, and I'm going to go down to my graph right here. This is my travel time graph that's done in minutes, so I'm going to have to convert my seconds to minutes. Okay, so what I can do, this is the point where I take my separate sheet of paper, an index card, note card, post-it note, whatever you want, and I'm going to use this to try and figure out where my epicenter is. So I know I have 135 seconds, so this is actually going to be the same as 2 minutes and 15 seconds. If I just convert this from seconds, this is 2 minutes and 15 seconds. Okay, so all I do on my graph is I'm going to put a line on my separate sheet of paper at 0 minutes and go to 2 minutes and 15 seconds, right about here. 2 minutes, 15 seconds. Okay, so now I know everywhere between these 2 points is going to be 2 minutes and 15 seconds. If I move it up here, that's a difference of 2 minutes and 15 seconds. If I move it over here, 2 minutes, 15 seconds. So what I want to use is I want to use the P and the S wave arrival times to try and figure out where my distance is. So all I do is I move this around and I keep the 0 minutes right on my P wave, and I try and get the top line, the 215, right on my S wave line. So I just move this around here until I get both of them together. So right about, here should be about good, and I got to make sure I'm straight up and down too. Okay, so now I would drop a line straight down, and from there I should be able to figure out my distance. So here's my line. I'm at 1,000, 200, 400, 600. So I should be at a distance of 1,600 kilometers. Okay, so I take that up here and I get 1,600 kilometers. Okay, so I've got my P wave arrival time, S wave arrival time, figured out the lag time, then I got the distance from the city. Already got all that information. What I can do next is I can figure out where it's going to go on my map. So I got to keep this number in mind, 1,600 kilometers. I'm going to go to my map. This is where I need my compass. Okay, so what I can do with my compass is I can extend it, and if I put the pointed tip on at 0, and I extend my pencil all the way out to 1,600. Okay, so now I know everywhere I move my compass is going to be 1,600 kilometers. Okay, see how I've got 500 here, 1,000, 1,500, and then I add an extra kilometer, 100 kilometers, because each box is 100 kilometers. Then what I can do is I know everywhere that I move this is going to be 1,600 kilometers. So if I take this and I draw myself a line, or a circle, I know that somewhere along this circle I had an earthquake. Whoops. And if I fall off, that's okay. Okay, somewhere along this circle there was an earthquake. Okay, so there's an infinite number of spots I can see on here. I'll go over it in the pen so you guys can see it a little easier. So somewhere on this circle I had an earthquake. I don't know where. There's an infinite number of places I could get an earthquake. Okay, and this one's usually the tricky part just because some of the compasses are a little bit tougher to use than the other ones. If you get patient, it's not too bad to use. Okay, next part I'm going to do. I've got my Chicago one down. Okay, so I already did this one. Now I'm going to do my other two. Okay, so I go back to my P and S wave arrival times. I'm going to do the same steps. We'll do these next two steps so you guys can figure it out on your own after that. Okay, so I do Kansas City. Here's my first arrival of the P wave. And that one's going to be at about 58 seconds. And then my S wave is way down here, almost at 175. I'm going to call that 174 seconds. Okay, so I just look for the P, then the S wave. Then I go back to my table. Okay, so I can fill out my P wave arrival time. We said was 58 seconds. My S wave arrival time then was 174 seconds. Okay, then I just do my S minus my P. So if I walk through that, it's 174 minus 58. Cancel this. I get 14. I get 6, 116 seconds. Okay. From there, I can figure out my distance from the city. This is where I use my graph down here and my piece of paper, my scrap piece of paper. Okay, so it was 116 seconds. That's almost 2 minutes, not quite, so a little bit shy of 2 minutes. So I'm going to go put a mark at 0 and a mark just shy of 2 minutes. So here's 0 minutes, and this is it should be 1 minute and 56 seconds. Min to second. Okay, now I know everywhere I move this is going to be 1 minute and 56 seconds apart. So then all I do is I find where my intersection of those 2 points for the S and P line occur. So I drop this down. I know that I'm just about at 1200. Oh, you can't see that. I'm just about 1200 kilometers from the epicenter. Okay, so I can take that number, put in my 1200 kilometers. Now I've got a distance from the epicenter for Kansas City. Okay. Next thing I do is I go right back to my map and I got to find 1200 kilometers. Okay, so I take my compass, put one end on 0, and I put my pencil end on 1200. Should be right there. Let me count it out to make sure. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Good, that one right there. And this point right here. Now my compass is set to be 1200 kilometers from any point. So everywhere between these 2 points is going to be 1200 kilometers. Okay, so what I can do is take my compass. Okay, I already got one intersection of my circles. There's my second intersection. I'll draw the full circle just cause, but you really don't even have to draw the full circle at this point. Okay. I'll draw this in so you guys can see it a little easier. This circle goes all the way over here. And again, you don't have to draw the whole circle if you've got this much done, simply because I know the earthquake's not going to be way over here because it's not near the intersection of my circles. So now I know that I've got an earthquake right here, or I've got an earthquake right here. Okay, so it's either just off the shore of Texas or it is in, that looks like Utah to me. Maybe part of Idaho, somewhere up here. To figure out this last one, all I have to do is I do the same steps as I did before. I find out the P and S wave arrival time for Santa Barbara, lag time, distance, and then I draw my new circle from Santa Barbara. And just to be safe, I can do it for Seattle too, and hopefully I should get an intersection of all the points. Okay, you only need to do 3 But if you do a fourth one, that makes it so it's a little bit more accurate and precise. If you guys have any questions, please leave a comment. And other than that, good luck. You should be able to figure out the epicenter based on your data from Santa Barbara and Seattle. Good luck, guys. See you later.